Hello. In this video, we're going to continue studying radicals, and we're going to look at the square root of an underlying graph. Now, you can sort of think of this like a transformation. It's a little bit more general than just graphing the square root of, let's say, x or x plus 2. We're actually going to graph the square root of f of x, the square root of a given graph. So here we have some random graph, looks a little bit like a hockey stick, and we want to find the square root of this whole graph. Now, what that means, if you want a little table of values here, is it means we can take our x and our fx values. So we notice here we start at 0, and we go to 6. So 0, 1, 2, 3, 4, 5, and 6. Fx is going to be -1, -1, 0, 1, 2, 3, 4. And what we need to do is we need to calculate the square root of f of x. In other words, we need to square root those y values. So these things all need to get square rooted. And when you do that, something weird happens, because what's the square root of -1? I don't think we can do that. That's going to be undefined. So there's actually going to be no point here. What's the square root of -1 here again? Nothing. This is undefined. Now the square root of 0, we can do that. Square root of 0 is just 0. Square root of 1 is just 1. Root 2, unfortunately, it's kind of like a decimal. It's like about maybe between 1 and 2, like 1.4. Root 3, it's also a decimal, but root 4, okay, we can calculate that. We got 2. So let's look at these 3 points that at least are nice numbers, and let's put them on the graph. So we have the point 2, 0, the point 3, 1, and the point 6 and 2. All right. Now we have those 3 points, and we could just say, well, okay, just connect the dots, and boom, we're done. But we need to have a radical shape. So the graphing that we've done before will inform our shape. Because when we connect these dots, we want to have sort of that radical shape, you know, like sort of that looks like an arc, looks like a rainbow almost. Oh, I guess a rainbow go all the way around, but I would say an arc, a radical shape. And so here, as we connect the dots, sort of want something like that. And the examiners, when you go to do this on the final exam, it's crucial that this little portion here, that we see like a bend to it. If you just go straight from these 2 points, you're going to lose a half mark because you don't have that nice radical shape. But we have here looks pretty good. And you might say, well, okay, but what about the root 2 and the root 3? Well, I mean, I guess if you wanted those points, you could have added them on the graph. You know, this is 4 and root 2, and this is 5 and root 3. But because they're decimals and we don't really know what they are, it's harder just to kind of like get the precise location. The whole numbers are the ones that really help lock in your graph. And so I tend to avoid putting the extra ones on there. So again, what's our strategy here? Well, we start with our little table of values. So the red graph here, we make our table. And then we go ahead and square root all the y values. The x values stay the same. And if you have a negative value, you can't square root it. So now looking at the graph, you can kind of see, oh yeah, this section of the graph was below the x-axis. The y values were negative. And so there didn't end up being any square root graph. This is all just disappeared. Here, the square root of 0 is 0, the square root of 1 is 1, and the square root of 4 is down to 2. And so you could almost get away without even doing a table, just grabbing those points and then connecting the dots with a nice radical shape. Now for a little extra practice, let's write out the domain and the range of the blue graph. Well, if you notice, it starts at 2 and goes to 6. So 2 to 6 in square brackets. For the range, it starts at 0 and goes as high as 2. So we'd have a range from 0 to 2. Okay, so I'd encourage you to pause the video and give this one a try. You have an underlying graph in red. And for fun, this one actually has a little arrow at the end. And I want you to sketch the square root of this graph. So pause the video and give it a try. All right, assuming you gave it a try, we'd have this portion of the graph just disappearing. because it's all got negative values, and so there's going to be no graph. We can't square root those negative y values. At 0, the square root of 0 is 0. So both of those are going to be in the same location. And here the square root of 1 is 1. So if we want, and we make a little table here, we could grab some of these key points. Right? At 2, we have a y value of 0. At 3, we have 1. And then when we go to make our square root of fx, square root of 0 is 0. Square root of 1 is 1. Now we had that other point I mentioned here at negative 2, that's got 0. And hey, look, over at negative 3, we've got a value of 1. So those are also really nice points, because when you square root 0, you get 0. When you square root 1, you get 1. They're perfect squares. But it takes a while for us to find another nice point. I think it's going to be right over here. This point, although I really shouldn't do it in blue because it's going to move. This point right here, I'll do it in red. At negative 6 and 4 is going to square root to negative 6 and the square root of 4, which is 2. So that point is going to pop down to here. Now the next point that would be nice would be up at 9, because 9 is a perfect square, but the graph only goes to 5, 6, 7, so we can't really get another point. All right, so we have these points, and we can connect them with a radical shape. Here we just get like a little arc, but it doesn't keep going because there's no more red graph. So we just get like a little bump. On this side here, we connect it with that nice radical shape, and because this graph does have an arrow, we get an arrow on our blue graph. And, well, there we go. This is the nice, beautiful graph of the square root of f of x. Now for practice, we're going to go ahead and do the domain and range. So let me just erase this part here so we can see the initial red graph. And we're going to do just lots of practice here for domain and range, because I know it's a little tricky for students. So let's do the domain and range for the red graph. Looks like the domain, it goes all the way to the left, so negative infinity. And to the right, we stop at 1, 2, 3. So negative infinity to 3. Again, those round brackets around the infinity because it's not a number, square brackets around the 3. The range looks like it goes down to negative 2, and then it goes up to positive infinity. Okay, pause the video and see if you can get the domain and range for that blue graph. Okay. So the domain is going to go negative infinity to negative 2 over here. But then we have a gap, and it doesn't pick up again until we get to the 2. So that's going to be a union, 2 to 3. For the range, it looks like the lowest value is 0. And then because it keeps rising with that radical shape, we'll go all the way to infinity. Now again, if you're a little bit confused by this U shape, it means union, okay? This stands for union, and it's a way of putting two sections together, because if you notice, the blue graph has one section here and one section here. So we have a domain that is like sort of, if you were used to writing it with the set notation here, you would say x is less than or equal to negative 2, and then you say and x is, between 2 and 3. And so the way you say that, well, either, but maybe not and, maybe you might say or, maybe you might say x is less than or equal to negative 2, or x is between 2 and 3. And that's the thing, is kind of the and the or sort of gets students a little confused. You're trying to say that x could be these values, but x could also be these values. And I find that this just ends up being a little bit clumsy. And so the union is a lot cleaner. You just write the first interval, then you write a u, and then you write the second interval. And the u means to join together, like a union, like a joining together. And so it says the domain is this section and this section. All right, so given this graph of fx, let's graph the square root of fx. And then again, you can do the domain and range for extra practice. So go ahead and pause the video and give it a try. All right, so I'm going to try just graphing it without doing the table. So again, I'm looking for nice values. These are all negative, so they're gone. This is going to be 0. Square root of 0 is 0. Square root of 1 is 1. And square root of 4 is going to pop down to 2. Square root of 1 is 1. 0 is 0. Now I need to join all these points with a nice radical shape. Something like that. Perfect. What's the domain? Looks like we go as low as -1 and up as high as 7. And the range is from 0 to 2. All right, we got one more. Given the graph of fx, let's sketch the square root. Go ahead and pause the video and give it a try. Okay, again, all of this underneath is going to disappear. So really what we have is just the zeros. And, oh, this is a little tricky. This looks like 1. So I guess this point will be the same. And then over at 4, I guess I sort of have a point here at 4. So that'll drop down to kind of 2 right there, but it's not really a clear x value. Same thing over here. This point at 4 is going to drop down to the 2. So I kind of just have to eyeball it here. It should look, I guess, like this maybe. And this one I really think benefits from not making a table, because the location, like the x values here, it's like, where even is that? Is that like 1.5, 1.4? It's not exactly on a grid point, but because the x value remains the same, you can just kind of eyeball it. You can say, well, this is where the graph takes a value of 4. And so I know the same location is going to be here. We don't change the x values. We just move the y value from 4 down to the square root of 4, which is 2. Now again, let's do some extra domain and range practice. So we'll do the red graph just for fun. The domain looks like -infinity to infinity because you have arrows on both sides. The range is from -2 at the bottom. Oh, sorry, maybe, what was that, negative? That was like -1. -1 to infinity. For the blue graph, the domain looks like -infinity to -1. Union 1 to infinity. And the range, you start at 0 and you go all the way up, so 0 to infinity. Let's go ahead and take some notes. This is basically just a single concept, graphing y equals the square root of fx. And so the steps here are you square root y values. X values stay the same. Square root of a negative number gives no graph. And you want to look for nice y values. In other words, square root of 4 is 2, square root of 1 is 1, square root of 0 is 0. So let's go ahead and just make a basic graph here. Something real easy. Let's go here to here to here to here and back down to here. Okay. So this will be down at -1. This will be up at +1. This will be 1, 2, 3. So here is your graph y equals fx, and your goal is to sketch y equals the square root of fx. So go ahead and pause the video and give that a try. All right, so if I was to make a little table here for us, we'd have x values at -1, 0, 1, 2, and 3. The f of x values would be -1, 0, 1, 1, and 0. And the root, well, nothing would happen here because you can't square root a negative. This would be 0, 1, 1, and 0. So they're actually going to be all the same points. Kind of neat. But we have to add that radical shape. So here, we get a bit of a an arc. And then across here, well, the square root of 1 just stays 1, so it actually slides along the graph. So it looks a little funky, right? We've got kind of a radical shape there, sliding along the top. Cool, there's our graph. So for extra practice, you should try worksheet 4 and 4.5. You can maybe add 1 or 2 to your notes here. And then any things to remember, you might want to work on your domain and range, especially remembering the U, which stands for union, if you haven't done that a lot before. All right, hopefully you enjoyed this video. And as always, thanks for watching.